The next topic is input and transfer impedance. Input impedance of a line. What is Zin and input impedance of a transmission line? Input impedance of a transmission line is defined as the impedance measured across the input terminals of the transmission line. It is the impedance seen looking into the sending end or the input terminals. It is also the impedance at the input into which the source must work when the line is connected. Also known as driving point impedance, and is denoted by Zin, which is equal to Bs by Is, and also known as driving point impedance. The voltage and current expressions in hyperbolic form is given by E equal to Er cos h square root of Zys plus Ir Z0 sin h root of Zys, and I equal to Ir cos h root of Zys plus Er sin h square root of Zy by s. To find input voltage and input current for the transmission line of length L, replace S by L and square root of Zy by gamma, E by Es and I by Is in equations 1 and 2. Then we get 3 and 4 as shown in these equations. That is Es equal to Er cos h gamma L plus Ir Z0 sin h gamma L. Is equal to Ir cos h gamma L plus Er sin h gamma L. Input impedance Zs equal to Es by Is. Therefore, equation 3 divided by equation 4 gives Zs equal to Z0 into Zr cos hyl plus Z0 sin hyl divided by Z0 cos hyl plus Zr sin hyl. Equation 5 is one of the standard form of input impedance of a transmission line. The second form is to find input voltage and input current for the transmission line of length L. Replace the S value by L root Zy by gamma, E by Es and I by Is in equation 1 and 2, and by getting Es by Is, we can get Zs equal to Z0 into e power gamma L plus Zr minus Z0 divided by Zr plus Z0 e power minus gamma L divided by e power gamma L minus Zr by Z0 divided by Zr plus Z0 e power minus gamma L. Equation 8 is the another form of input impedance of a transmission line. Input impedance is given by Zn of L equal to Z0 ZL divided by ZL plus Z0 tan h of gamma L divided by Z0 plus ZL tan h of gamma L. Substitute tan h of j theta equal to j tan theta and gamma equal to j beta, Z0 tan h gamma L equal to j Z0 tan beta L. For a lossless transmission line, input impedance is purely imaginary and is given by gamma equal to j beta. Therefore, the input impedance is given by Z in of L equal to Z0 into ZL plus j Z0 tan beta L divided by Z0 plus j ZL tan beta L. Matched load. Another special case is when the load impedance is equal to the characteristic impedance of the line, that is, the line is matched, in which case the impedance reduces to the characteristic impedance of the line, so that Zin equal to Z0 equal to ZL. Short line. For the case of shorter load, that is ZL equal to 0, the impedance is purely imaginary and a periodic function of position and wavelength. Infinite line. When the length L of the line is infinite, i.e. L approaches to infinity, thus Zin equal to Z0. Hence, it is concluded that a line of infinite length, irrespective of the type of terminating load, has an input impedance Z0, thus behaving like a line of finite length terminated in its characteristic impedance Z0. Transfer impedance. Input voltage of a transmission line is Es. By substituting the values, we get Zt equal to Zr cos h square root of Zys plus Z0 sin h of Zys. Assessment. Define input impedance of a transmission line. Give the standard form of input impedance of a lossless line. What is infinite line? Compare the input impedance of a half wave and quarter wave lines. What is transfer impedance? Thank you.